Now the next electrical quantity, one more important electrical quantity is the power. So what is power? It is denoted by P, and it is the nothing but the rate of change of energy or the work done. Energy and work done are the same thing. Okay. Now what about the units? These units are, if you take in terms of the energy, then it is joules per second. Okay, or you can simply say watts. 1 watt is equal to 1 joule per second. So what is the mathematical expression? The power P is equal to dW by dt, rate of change of energy. So this is P as a function of energy, power as a function of energy. What about the work done? The work done or the energy is equal to integral T1 to T2 P dt, or just like in the case of charge, you can write as P of T dt plus the initial energy. Okay. Now this is one part of it. This is a relationship between the work done and power. Now what is the relationship between power and other electrical quantities, the voltage and the current? Okay. So we will start from the expression P is equal to dW by dt. Okay. Now the work done, you can write dW by dQ into dQ by dt. We are doing nothing but just multiplying and dividing by the charge, elementary charge dQ. Okay. So now what is dW by dQ? This is nothing but the voltage. And what is dQ by dt? This is nothing but the current. So the power is given by V of t into I of t. Okay. So you can write this as P of t. This is called as instantaneous power. There are many other kinds of power that we are going to deal with, and instantaneous power is like the basis for all of those powers. Now just like the law of conservation of charge, we have the law of conservation of energy. Okay. So what does this state? Energy can be neither created nor destroyed. Energy can neither be created nor destroyed. Okay. From this law of conservation of energy, we have one very important result, that is the power consumed in a circuit is equal to the power supplied. Okay. So if you take a voltage source or a current source, then whatever power it is supplying, only that amount of power will be able to consume, right? So the network will not be able to consume more power than the supply is giving, right? So from here we get the summation of power is equal to 0. That means consumed and supplied, both of them, if you add algebraically, then it is going to be 0. Or a better way to represent is the power delivered, sum of power delivered is equal to sum of power consumed or absorbed. Now the next important point is the sign convention of power. So we will see what this is. If you consider a circuit element, okay. Now let us say the polarity is given like this, positive and negative, and if the current is flowing into the positive terminal, okay, I enters positive terminal, or you can say leaving negative terminal. This is when you say that the power is being absorbed. Okay. And in this case, the power is taken as greater than 0. This is the sign convention. Okay. Power absorption is considered to be positive. And in the opposite sense, that means the polarity is, let us say, plus and minus. Now the current is leaving the positive terminal. Okay, then in this case, see, I leaves positive terminal, or it is entering negative terminal. In this case, the power is said to be being delivered or supplied, and in this case the convention is taken to be less than 0. Okay, so this convention wherein power absorbing is greater than 0 and power delivering is less than 0, this is called as the sign convention of power. Okay, and this convention is specifically called as the passive sign convention. Okay, so there is a reason for this as well. We will discuss it a little later, why it is called passive sign convention. For now, you just understand that this is the sign convention.